Not long ago, Microsoft CEO Satya Nadella said something that stuck with me. Running 100 agent sessions, the cognitive load it dumps back on you as a human got so heavy, he said he needed a whole new UI. And prepping the context layer well enough for your plan to run at its most efficient. That's where the real magic is. Today's video, Part 1, Where the Problems Come From. 8 Real-World Scenarios. Part 2, How to Fix Them, a hands-on demo. Let's start with the most common context problem. Getting interrupted happens every day. When you come back, the AI usually still remembers the project. For simple tasks, that's fine, you can just dive back in since a mistake doesn't cost much. But on complex work, you can't be sure it remembers every detail, every constraint, every decision you'd already settled on. So you have to re-explain, reconfirm, or the work quietly drifts off track. In a long session, the context window has its limits, early content gets trimmed or dropped, and even inside that window, attention to the middle fades. You never quite know what got missed, so you end up stuck in a loop. Execute, hit a snag, re-explain, fix, again and again. And when context gets auto-compressed or summarized, the careful process and detail you built get flattened into something that just sounds right, not the plan you actually made. According to research from Santilli, Claude Code's auto-compaction can crush 132,000 tokens down to just 2,300 to 98% of your reasoning and conventions, flattened. When a project can't be finished in one sitting, and that usually means it's a complex one, reopening it means realigning on context and detail every single time. By the time you're actually back to work, you've already burned through a good chunk of your energy just getting there. Switch tools mid-project, and what you lose isn't just the interface, it's everything that tool had already worked out, what it tried, what it ruled out, why. The chat history's too long to realistically copy over, you wouldn't even know where to start. A plan doc travels better, but it's just a snapshot of what step you're on, not the reasoning that got you there. Run agents in parallel, and the real bottleneck isn't the AI's output, it's your capacity to review it. Past 1 or 2 sessions, you're not coding anymore, you're dispatching. Tracking which session depends on which file, catching the one that's quietly drifted off track before it costs you more to fix. The hard part about team handoffs is how to transfer state, what was done, what was tried, what was ruled out, the implicit assumptions that felt too obvious to write down, the edge cases you discovered but never got around to documenting. A static handoff document is a compression event. The artifact is always smaller than the understanding it represents. The longer the list, the more time to read, and the more tokens to repeat. And something always gets missed. Dangerous command incidents have already happened many times in 2026. They're closer than you think. Docker security team put it well. The agent inherits your full permissions, and the deciding and the doing happen in the same cycle. You can't intervene in time. And after it happens, grabbing the right evidence under pressure is harder than you'd think. Git AI can tell you which lines AI wrote. But who proposed the direction? Who rejected the wrong approach? What exactly was decided? Scattered across chat logs, hard to search. And co-authored by? 2 commands forge any author. In daily work, developers don't build the habit of keeping an evidence trail, so when you need to prove something, you're empty-handed. And when danger hits, gathering evidence under pressure and panic is a challenge. Next, let's see how to fix them with one protocol file plus a visual UI. WRF-Deck is not another AI editor. It's a visual workspace. The WRF protocol file is highly structured, carrying both the project plan and full execution state. They work together to solve the problems I mentioned earlier. I'll demonstrate each part below. First, click Get Templates. It will download automatically to your local folder. Then, have your AI tool fill in this template with a step-by-step plan based on your project requirements. Click Import to start, and import your project plan into WRF-Deck. The plan steps and content will appear in the left-hand roadmap. The middle IDE-like panel shows the current execution focus and the next steps. Click the Copy Next Step command button. It generates a dynamic structured instruction for the current step. Every step requires the AI to update the protocol file according to the rules. Filling in execution status, checkpoint records, command declarations, and more. The command dialog also has an additional instruction input field, where you can enter creative directions, constraints, or correction notes. After filling it in, the human contribution record checkbox lights up. check it, and your instructions will be recorded separately as human contributions, ready to export when the task is complete. You can click the Copy with Notes button, paste the structured command with notes into your AI tool for execution. If you don't need to add human direction notes, you can simply click Copy and paste the standard structured command. This saves you from manually typing instructions and avoids the risks of casual, unstructured prompts. Click Copy Branch Task command to start a temporary branch task, debug, or anything off the main track. The main task stays untouched during that time. Once the temporary task is done, click Copy Next Step command again. The workflow automatically returns to the parent step, letting you continue the main task from where you left off. Now let's start the demo. I have no additional instructions this time, so I'll just click the Copy button and paste the structured command into the AI. The AI starts executing. You might wonder, why does the AI write content back into the WRF file step by step? The key is that the rules aren't statically written in a document, but turned into concrete structured instructions for each step. At each step, the AI doesn't hear vague requirements. It gets precise commands on how to update the WRF file. This instruction structure has been researched and tested. The AI isn't passively following a protocol. It's repeatedly reinforced at the exact moment its attention is most focused, naturally producing content that matches the required format. When every step is built this way, following the protocol becomes the most natural, default path for the AI to complete the task. In internal testing and real-world use so far, almost all major AI tools have written it back accurately without exception. When step 1 is finished, the corresponding C001 task in the left panel is checked off, and the middle panel updates with the progress. The execution highlights and completion time of C001 are automatically recorded in the completion history section, making it easy for the team to review. The AI has now finished reporting and is waiting for the next step command. Let's run one more step. WRF Dr. MJS is the WRF protocol structural validator. If there are errors, the AI will automatically go back and fix them. Next, I'll show how context-related problems are solved. Copy step handoff, used for switching AI tools, or resuming work after a short break or interruption. One-click copies the full execution context of the current active step. Project goals, step positioning, status, completed checkpoints with evidence, current execution state, and a preview of the next step. It includes safety instructions, preventing the receiver from automatically advancing the step. Copy full handoff, used for long interruptions, switching between multiple tasks, or one-click handoff between team members. It hands off a complete project snapshot, project strategy, all completed steps with evidence, current execution state, next step plan, as well as safety stop points and alignment requirements. All content comes from the local WRF protocol file that fully records the execution state. Of course, this protocol document can also be used for direct handoff, for historical unfinished tasks and team tasks. You can even hand off via email. The moment the protocol is imported into the WRF Deck visual workspace, all execution state is restored instantly, and the task continues directly from the breakpoint. Parallel multitasking. You can assign a separate WRF protocol file and a separate WRF Deck workspace to each task. You can pause, switch AI tools without losing the state of any task. Click the Export Human AI Contribution Evidence button, and a zip will download. It contains the complete WRF protocol file and the Human AI Contribution Summary Report. Your count of leading instructions is shown here, and your instruction content is shown here too. Next, let's demonstrate the dangerous command sentry and evidence features. Any terminal command, file deletion, or system change operation is recorded in the command ledger. This is not letting the AI decide on its own, nor is it a static suggestion. Instead, every time the next step is executed, the user triggers Copy Next Step command with one click, automatically generating and injecting a structured instruction into the AI context. Now let's click to resume the task execution. When a command ledger record matches the built-in dangerous command pattern library, that command is marked as dangerous, and its status is set to pending. The AI must stop and wait for user confirmation. Even if the dangerous command isn't correctly recorded in command ledger, Sentry's raw CLI pattern scan can still detect it from traces in the persisted protocol. At the same time, a red warning banner pops up at the top of the WRF deck workspace, reinforcing the alert. You can also first click Lock Sentry Evidence to lock the current WRF source file and the event summary and generate a hash proof. You can verify it with one click, export it, or submit it to OTS. Make evidence a daily habit. Drag and drop to save it, building your evidence chain. You never need them until you do. The WRF protocol is open source with a lightweight SDK. Link in the description.